All right, so section 9.3 talks about simulations and applications in probability. So one of the applications of probabilities we're going to talk about we're going to talk about odds. So it says odds. People talk about odds in favor and the odds against a particular event's happening. For example, if the odds in favor of an event are 4 to 1, that means if the circumstances surrounding the event are to occur many times, for every 5 times the circumstances occur, we can expect the event to happen 4 in those times and not to happen 1 time. So it says the interpretation of this gives the following intuitive results. So the probability that an event is going to happen would be 4/5, and the probability of an event that it does not happen would be 1/5. Okay, so let's see if we can figure out a little bit about odds in favor of an event here. So it says odds in favor of an event. In an experiment with equally likely outcomes, the odds in favor of an event E can be found using the following formula. The odds in favor of event E is the number of outcomes favorable to E divided by the number of outcomes unfavorable to E. Okay? So it says, for each of the following, find the odds in favor of the given event. So part A says, rolling a number less than 5 on a die. So when we roll a die, we can either end up with a 1, 2, 3, 4, 5, or 6. Okay? So we want to figure out what are the odds in favor of rolling a number less than a 5. So how many numbers are less than 5? There are 4 numbers less than 5. With odds, we typically write them like this. We'll write the first number and then a colon and then the second number. How many numbers are not less than 5? Well, the other 2. So 4 to 2, we can reduce these numbers by dividing them both by 2. So that would give me 2 to 1. Okay. So one thing I want to mention, when we're talking about our odds, if we were going to say, think about probability of rolling a number less than 5. Okay, think about that in terms of a probability. How many numbers did we have? Well, we had a total number of 6. How many were less than 5? 4 of them. Okay, so what would not, so less than 5 with a negation on it, little prime, would be 2 out of 6, right? So when we're doing odds, we're going to take the number that are favorable to the number that are not favorable. Okay. All right, part B. Part B says tossing a heads on a fair coin. Okay, so we can either end up with a heads or we can end up with a tails, right? So we're going to figure out, okay, we're going to take a look at the number of outcomes that are favorable. So it's 1, 2. How many are not favorable? 1. So either heads, which is favorable, to the tails, which is the unfavorable, right? Okay. Now, part C says drawing an ace from an ordinary 52 card deck. So remember what a deck of cards looks like, right? We got 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. Now, I'm only going to write this once. I know in a regular deck of cards, we have that for the hearts, the diamonds, the clubs, and the spades. When you write it down once, this is already sort of a reduced version, okay? Because I don't have the same thing written down 4 times, okay? So if I were to count here, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 unique cards here, okay? Out of those 13, how many of them are an ace? Well, 1 of them is. 1's an ace. How many are not? The other 12. Okay. Part D says drawing a heart from an ordinary card deck. Okay, so think about it this way, right? We have hearts, we have diamonds. I know I'm not doing them in the right colors. We have clubs, and we have spades, right? So we have 4 different suits, right? How many of those different suits are hearts? 1 of them. How many are not hearts? 3 of them, okay? And again, when I like thinking about it this way, y'all, is that I'm already looking at it in a reduced fashion. Okay, I could say if I was looking at the entire deck of cards, I would say 13 are. How many aren't? Well, whatever 52 minus 13 is, and then I would have to start reducing, but I can already reduce it this way. Okay. Alrighty, let me move down a little bit. Okay. So it says a fair die is tossed. So remember what a fair die looks like. 1, 2, 3, 4, 5, 6. Okay. What are the odds in favor of a cube showing a 4? How many are 4s? One of them. How many are not? The other 5. Okay. When a single card is drawn from a 52 card deck, find the odds in favor of getting the 10 of hearts. So if I look at my deck of cards, right, just think about it for a minute. If I were to think about a deck of cards, how many 10 of hearts are there? There's only one 10 of hearts. So how many are not? Well, if there's 52 cards total, the other 51 would not be the 10 of hearts. Okay? All right. So let's take a look at this next problem here. And it says a basketball player with a free throw shooting percentage of 80% gets fouled and goes to the line to shoot 2 free throws. What are the odds in favor of her making her first shot? Okay, so let's think about this first part. What does this mean? A basketball player with a free throw shooting percentage of 80%. That means that the probability that she's going to make her free throw is 80 out of 100. So what would be the probability that she would miss it would be 20 out of 100. Okay? Because if it's 80% means 80 out of 100. I know I can reduce those fractions. I'm just thinking about it like this right now. And so the probability if she's going to make it would be 80%, and the probability that she's going to miss it would be 20%. Since we're looking for the odds in favor, right, we're going to take the number of favorable outcomes, which is 80, to the number that are unfavorable, which would mean that she would be missing it, to 20. I can divide them both by 20, and that will give me 4 to 1, right? Okay, so when we're talking about the odds in favor of an event, we had the number of outcomes favorable first, and then the number of outcomes unfavorable second. Well, now when we talk about the odds against an event, it's going to be the number of outcomes unfavorable to the number of outcomes that are favorable. Okay? So let's take a look here at this next problem. It says, if it has been determined that the probability of an earthquake occurring on a certain day in a certain area is 0.1, what are the odds against an earthquake? Okay, so the probability that we're going to have an earthquake is 0.1. So remember what this means. This is like the tenths position, that's the hundredths position. So it's 1 out of 100, okay? So what's the probability that we don't have an earthquake? Would be 99 out of 100, right? So the number of outcomes favorable, 1, this would be favorable. And these would be unfavorable. Okay? So we want to first write the number of outcomes unfavorable, 99, to the outcomes that are favorable, 1. So 99 to 1. Okay? Let's see. If the probability of rain for the day is 65%, what are the odds against rain? Okay, so let's see if we can figure out. The probability that it's going to rain, 65 over 100. So the probability that it's not going to rain would be 35 over 100. These are favorable. These are unfavorable. Okay, and we're looking for odds against, so we're going to write 35 to 65. I'm going to just divide both those numbers by 5. That'll give me 7 to 13. Okay. All right. So it says for our next problem here, it says tote boards at racetracks list the odds that a horse will lose the race. Okay, the odds that the horse will lose. If the probability of a horse winning the race is 1/11, what are the odds listed on the tote board? Okay, so that means that the probability that the horse is going to win is 1 out of 11, and the probability that the horse is not going to win would be 12 out of 11, right? So we're looking at the odds that the horse is going to lose the race. So I'm going to take the 12 first to the 1, right? 12 that it's not going to win to the 1 that it will. Okay. All right. So for the next part here in 9.3, we have something that's called expected value. So the expected value of an experiment, of an event, of an outcome is going to be the probability that the event happens times the amount that we're going to win or we're going to lose. And it's kind of easy to explain if we do a couple of problems, okay? So let's take a look here, and it says a contractor is considering a sale that promises a profit of 20,000 with a probability of 0.7, or a loss of 7,000 with a probability of 0.3. What is the expected profit? Okay, so we're going to do this. We're going to say we're going to win, or we're going to earn $20,000. Okay, and we have the probability of 0.7 of that happening. And we're going to have we might lose, right? It's a loss of 7,000. If it's a loss, I need to think about it as a negative 7,000 with a probability of 0.3. Okay. And now we will find our expected value. So let me grab my calculator again right here. Let me turn it on and move it this way a little bit. Okay, so let's clear it out. And I'm going to take 20,000 times 0.7 plus negative 7,000 times 0.3, and that's going to give me 11,900. So to sort of explain what this means is that if we were to sort of, over the long run, try to make this deal, say every day or every year or every month, say we were to do this deal every month for a year. On average, each time, there's going to be times when we're going to make money, and there's going to be times when we're going to lose money. But if we were to sort of average it all out, suppose we were to do it 12 times, once in January, once in February, all the way through December. And we know that certain months we're going to make 20,000 and certain months we're going to lose 7,000, right? But if we were to take all that money and add it all up and divide by 12, on average, what we would have said is each time we earned about 11,900. Okay, that's what expected value really means. Okay. All right. So for the next part here, let's see if we can figure out this next problem. And it says, a business bureau gets complaints as shown in the following table. Find the expected number of complaints per day. Okay, so we can do this. Suppose we get no complaints. Well, the probability of that happening is 0.4. The probability of getting one complaint is 0.11. The probability of getting two complaints is 0.26. The probability of getting three complaints is 0.28. The probability of getting four complaints is 0.19. The probability of getting five complaints is 0.12. So we're going to find, again, the expected number of complaints per day. Okay, so let me move this over. Okay, so 0.4 times 0, we already know that's 0, but I'll type it in here. Plus, okay, 1 times 0.11 plus 2 times 0.26 plus 3 times 0.28 plus 4 times 0.19 plus 5 times 0.12 equals 2.83. So this is the expected number of complaints we can have in a day. Somewhere between 2 and 3, but probably closer to 3, right? Probably closer to 3. Okay. All right. Okay, so the problem says suppose 9 quarters, 7 dimes, 2 nickels, and 3 pennies are in a box. One coin is selected at random. What is the expected value of the money drawn from the box? Okay, so 9 quarters, 7 dimes, 2 nickels, 3 pennies. That gives me, let me see, 7 and 3 is 10, 9 and 2 is 11. There's a total of 21 coins. Okay, so let's find the expected value. All right, so out of the 21 coins, 9 of them happen to be quarters, and quarters are worth 25 cents, right? Let's see, out of the 21 coins, there are 7 dimes, so 7 out of 21, and dimes are worth 10 cents. Let's see, there are 2 nickels, 2 out of 21. Nickels are worth 5 cents. And then there are 3 pennies, 3 out of 21, and pennies are worth 1 cent. Okay, so guys, I'm going to think of these numbers here over 1, and let's see, 9 times 25. If I had 9 quarters, so I know 8 quarters would give me $2, so 9 quarters would give me $2.25. 7 times 10 would give me 70. 2 times 5 would give me 10. 3 times 1 would give me 3. Notice the bottom is all over 21. Now I'm just going to take my numbers and add them up. Okay, so let's turn it on. 225 plus 70 plus 10 plus 3 is 308. So we have 308 divided by 21. So if I take that number now and divide it by 21, we end up with, I'd probably round to 1 decimal place, 14.7 cents. Okay, so again, this is what the expected value means, right? The expected value means this. All right, so the next one here says, suppose you buy 1 ticket for $1 out of a lottery of 1,000 tickets, where the prize for the 1 winning ticket would be 500. What are our expected winnings? Okay, so there's 1,000 tickets. The probability that I'm going to win is 1 out of 1,000. Probability that I'm going to lose is a lot more. 99 out of 1,000, okay? So let's find our expected value. Okay, so if I'm going to lose, it's going to be 99 out of 1,000. And how much money am I going to lose? I'm really going to lose $1. I'm going to think of that as negative 1 over 1, okay? Now, the probability I'm going to win is 1 out of 1,000. And my winning ticket would, or my winning prize would be 500. But I want you to think about it. I had to spend $1, right? So that's why if I lost, I would lose my $1. But if I win, they give me $500, but I don't really get a profit of 500 because I had to spend that $1 to begin with, right? So my profit would really be $4.99 over 1, okay? So I'm going to multiply again. That's going to be negative 999 plus 499 all over 1,000. Okay, and let's see. What is negative 999? Negative 999 plus 499 should be what, 500? Negative, yes it is. So negative 500 over 1,000 would be, take my calculator, negative 500 divided by 1,000 is negative 0.5. So on average, I'm losing about 50 cents every time I buy one of these lottery tickets, okay? All right, let's do the next problem. Okay, so the problem here says numbers is a game where you bet $1 on any three-digit number from 000 to 999. If your number comes up, you get $600. Find the expected winnings. Okay, so guys, let's see how many numbers we're actually going to have. If we were going to go from 1 to 999, we would say, well, we know there's going to be 999 numbers. But because we're including that one, we know that there's 1,000 numbers to begin with, okay? So let's find the probability that we would win. Now, there's only one number that's going to be chosen, right? So the probability that I win would be 1 out of 1,000, and the probability that I lose, again, would be 999 out of 1,000, okay? So let's see if we can find our expected value. The probability that I am going to lose is 999 out of 1,000. Okay, I'm betting $1. So if I lose the dollar that I had. Now the probability that we said we're going to win is 1 out of 1,000, and if we win, we get $600. But because we really spent that dollar to begin with, we're really only making $599, right? This is almost real similar to the one we just did before. So notice this is 999 negative, right? Plus 599 all over 1,000. That's going to give me negative 400 over 1,000, which is a negative 0.40. So again, on average, each time I play this game, I'm losing about 40 cents, right? Okay, so the last problem I have here out of 9.3 says a racetrack tote board has the odds for horse listed as 5 to 1. Tote boards list the odds that a horse is going to lose. So this is losing, this is winning, okay? So guys, that means that my total number of options would be 6. So the probability that the horse is going to lose would be 5 to 6, and the probability that the horse is going to win would be 1 to 6. And then it says right here, in this case, what's the probability of the horse winning? Well, it would be 1 out of 6. Okay? And that is 9.3.